Hello everyone, welcome back to the world of STEM. Hope you all are doing well. Today we'll be covering loops in Java, or Unit 4 of the AP Computer Science A curriculum. There are two main ways to loop in Java. The first way to loop in Java is using a while loop. As its name suggests, the loop loops while the condition is true. Before each iteration, the condition is checked. If the condition is found to be false, it stops looping. As an example, you can use a while loop to count to 10. In this case, the condition that the while loop checks is if the counter variable is less than the value of 10. On each iteration, we increment the value of counter and we print out its value. The condition evaluates to false when counter equals 10, causing the while loop to stop executing and finishing our counting. Here's the output of calling this program. However, since the condition of a while loop is checked before every single iteration, if the condition is initially false, it won't loop at all. As an example, if we change the value of the counter variable to 11, the condition that counter is less than 10 is initially false, meaning that the while loop won't loop at all. I will add a print statement to add ease in identifying that the program has finished executing. Here is the output of running that code. As you can see, no counting was performed and the program finished executing without running the while loop. Similarly, if the condition is always true, the while loop will loop forever, causing it to become an infinite loop. As an example, if I change this condition variable to something that always evaluates to true, this program will count forever, as the while loop will always see that the condition is true. After executing the code, the counter increases rapidly and will eventually crash your program due to using too much memory. You can also halt a while loop early by inserting a control statement, such as break. For example, by inserting break in this loop, we can make the while loop stop immediately after one iteration, regardless that the condition is true. As you can see, after running the program, the while loop only iterates once, counting by 1, despite the condition being true, due to the break statement. The second way to loop in Java is through a for loop. A for loop consists of three parts: the initialization of a loop control variable, the checking of a condition, and the incrementation. For example, you can use a for loop to count to 10. In each iteration of the for loop, the increment statement is executed after the entire loop body is executed and before the condition is evaluated again. This causes the value of I to be printed out, then the value of I is incremented up till 10, where the condition then evaluates to be false. The output of running this program is that it prints the values of I from 1 to 10. Similar to a while loop, you can also halt a for loop early through the use of control statements such as break. For example, by inserting break into this loop, we can halt the loop immediately after one iteration regardless that the condition is true. As you can see, the loop iterates once, counting by 1, but then stops due to the break statement. Loops can also be nested inside each other, which is when a loop is inside another loop. When a loop is inside another loop, the inner loop must complete all its iterations before the outer loop can continue. As an example, here is a program with nested loops. As you can see by the output of the program, the inner loop always finishes looping before the outer loop goes on to its next iteration. Now, what are some applications of loops? One application of a loop is in reversing a string. By setting the loop counter variable at the end of the string and looping backwards until it reaches the beginning, we can create a reverse string. As you can see, by the output of the program, reversing the string Steve correctly produces the output EBITS. Another application of loops is in calculating statistics of some data or values of an array. As you can see, using loops can help us analyze the statistics of an array as we can traverse through each element and perform calculations. For example, by comparing each element with the minimum and maximum value, we can determine the minimum and maximum value for the array, and we can calculate the sum by adding up all the values, and average by dividing by the number of values, and mode by keeping track of the count of each element in the array. Thank you all for watching. If you have any questions, don't hesitate to put them in the comments box where we will do our best to answer them. Any suggestions are truly appreciated. If you really loved it, make sure to subscribe, like, and share so that we can be a greater help to more people. Thank you for watching The World of STEM.